Welcome to Understand the Math. Let's now look at two examples so that we can learn how to evaluate infinite limits, because these can be really tricky. In our first example, we have a function f whose graph is given, and we're asked to evaluate the following limits. Let's move this up so we can see our limits. The first limit that we're going to evaluate is the limit as x approaches 2 of f of x. Let's go up here and highlight 2, and then let's look at our function. As x approaches 2 from the left, we go to minus infinity, and as it approaches from the right, we also go to minus infinity, so this is equal to minus infinity. Let's look at part B. For this one, we're taking the limit as x goes to 5. Let's go up here then and look at 5. And our function from the left goes to infinity, and from the right, it also goes to infinity. So this is equal to infinity. Now let's look at C and D. For both of these limits, x is going to minus 3. So let's go up here and look at that on the graph. From the left, it's going to minus infinity, and from the right, it's going to plus infinity. Let's write that down. So the first one is coming from the left, and it's minus infinity. Second one is coming from the right, and it's plus infinity. Those two limits are different, so we can say for part E that the limit as x goes to minus 3 of f of x does not exist. So we write D, N, E. We have one more part, and this part asks us to find the equations of the vertical asymptotes. I always like to ask students this because I think it's just good practice. Notice that we have a vertical asymptote at minus 3, at 2, and at 5. And we can write the equations for these vertical asymptotes as x is equal to minus 3, x is equal to 2, and x is equal to 5. So just remember, any vertical asymptote can be written as x is equal to some number. Let's now look at our second example, and I think this is the hardest one of the entire section. In part A, we're asked to find the limit as x goes to 2 from the left of the function 4 divided by x minus 2. Whenever you evaluate a limit, the first thing you need to do is use direct substitution and just plug in what x is equal to. This is equal to 4 divided by 2 from the left minus 2. I think it's easiest to evaluate this if we draw a little number line, put a 2 on it, and then put a 2 from the left, and then say, okay, let's let this be equal to 1.99. I just think it's easier to have a concrete number in there. This then becomes 4 over 1.99 minus 2, which is 4 over minus 0.01. Now, that number is going to get a lot smaller as we approach 2 from the left. So it's going to be minus 0.000, lots of zeros, and then a 1. So what we have here is 4 divided by a really, really small number that's negative. So we can write this as 4 divided by 0 from the left. Up here in a box, I wrote down what this equals. If we have 1 and divide it by a really, really small number that's negative, it's going to equal minus infinity. So we can say that this limit is equal to minus infinity. Let's now look at part B. Again, we're going to start by plugging this in. So this is 4 divided by 2 from the right minus 2. We can think of a number 2 to the right as maybe 2.01, and then we subtract 2. So this is 4 divided by 0.01. So this is 4 divided by 0 from the right, just meaning it's really close to 0, but it's positive. And this is equal to positive infinity. I have that formula written up there if you want to memorize it. Now let's look at part C. We're going to begin by plugging in that x is equal to 0 from the right. So we have 0 from the right minus 1, all divided by 0 from the right quantity squared, 0 from the right plus 2. 0 minus 1 is just minus 1. And then 0 from the right squared is going to be positive, so we write that as 0 from the right. And then 0 from the right plus 2 is just 2. So we have minus 1 on top, and then a 0 that is positive times 2 gives us a 0 from the right. This is going to be equal to minus 1 times 1 over 0 from the right, which is minus 1 times infinity, which is equal to minus infinity.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.